Hello students, my name is Shashank Shekhar. So today we will do the NCERT Exemplar question of Chemical Kinetics. So the first question is of the type MCQ. We have to choose one correct option. So it says that the role of a catalyst is to change what? So for this you have to go to this, say our reaction profile. How does the reaction profiles look? So suppose this is the y-axis, this is the x-axis. So on the y-axis we have energy. Okay, this is energy in this fashion, and your reaction profile goes in this direction, so it proceeds in this direction. Now suppose without catalyst it will look like this. Okay, so this will be our, suppose this is a reactant energy, it will go up and it will go down. Clear? Now what we will do, we will apply catalyst or we will put catalyst. Then what will happen? So as we just add catalyst to the reaction, the rate of the reaction increases. How does it increases? By decreasing the activation energy. By how does it decreases? By decreasing the activation energy. Now you can clearly see that there is a gap. Okay, there is a gap between the reaction profile that is with catalyst and that is without catalyst. Okay. Now what it has done, it has decreased the activation energy. Okay, it has decreased the activation energy. So your answer will be activation energy. Equilibrium constant, if you talk about equilibrium constant, it depends upon temperature only and not depends upon catalyst, so it is wrong. About enthalpy of the reaction, so it is also not changing clearly. You can see that this gap is called that enthalpy of the reaction, it is not changing. Right? Similarly, Gibbs theory reaction of the energy of the reaction is also does not changes with the addition of catalyst. So the correct option will be activation energy. Next question. In the presence of a catalyst, the heat evolved or adsorbed during the reaction. What does it happen? So we are talking about the heat evolved or absorbed. So basically we are talking here about the del H of the reaction. So we have seen it from the graph only very clearly that this energy gap is not changed due to the addition of catalyst. Instead this energy is changed. So this will also remain unchanged. Okay, so this will remain unchanged. Next one, activation energy of a chemical reaction can be determined by, how it can be determined? Determining the rate constant at a standard temperature, determining the rate constant at 2 temperature, determining probability of collision, or using catalyst. How can we do it? Say, so suppose I'm telling that we can do it with the rate constant at standard temperature. So if we just take the Arrhenius equation, what else we need? So we need the A, we don't have A here. We need activation energy, we don't have EA also. Okay, so we have only K and T, so we can do it. What about this? Determining the rate constant at 2 different temperature. How can we do this? Can we use this? Say, so if you remember that it was ln K2 by K1 EA by R T, sorry, 1 by T2 minus 1 by T1 minus 1 by T2. So this was our equation, right? So even if we have at 2 different temperatures the rate constant K1, K2, and we have our temperature, we don't have EA. Okay, we don't have EA, and there we can use it to calculate it. Okay, so we can do it with this equation. If you remember our equation, so the Arrhenius equation was in this way. Just deleting this. So for 2 different temperature, it was ln K2 by K1 EA by R 1 by T1 minus 1 by T2. So this is our equation, right? This is our equation. So what do we have right now? So it is given that we have our K2, K1. Okay, we have our K2, K1 at 2 different temperature. So K2 is there, K1 is there, T1 is there, T2 is there. R we know already, hence we can calculate our EA. Okay, so we can, the correct option is B. So determining probability of collision, so this is also wrong. Okay, using catalyst, no, we can't do it. Fourth question, consider the figure and mark the correct options. So activation energy of the forward reaction is what? So it is basically E1 plus E2. That is the difference between the reactant and the activated complex energy. So E1 plus E2 is the activation energy for the forward reaction. So good. Is product less stable than the reactant? So which one is higher energy, reactant or product? Of course, product has higher energy, so it is less stable. So the correct option is obviously A. Now what about the second one? Activation energy of forward reaction is E1 plus E2. Good. But product is more stable. No, product is not more stable because it has a higher energy. Third question, activation energy of both forward and backward reaction is E1 plus E2. Is it right? So for forward, the energy is between reactant product is E1 plus E2. It is correct. But if you talk about the product, so if you go in the backward reaction, then the product will become reactant and the reactant will become product. Okay. So in that case, E1 will be the activation energy, right? So this, if this is reactant and this is the transient state, then E1 will be the activation energy. So this is wrong. This is also wrong. What about the fourth one? Activation energy of backward reaction is E1 and product is more stable than reactant. Again, this statement is wrong because of course for the backward it is E1, but product is not stable, reactant is more stable. So this is also wrong. So option A is correct. Next we have the initial partial pressure of system before decomposition of A was Pi. After lapse of time T, the total pressure of the system increased by X units, right? And become PT. So before decomposition, so we can write here, that before decomposition means we have only A here. So our equation is A is going to B plus C. And at initial time, only A will be present. So all the pressure that is exerted on the vessel will be due to our A only. So initial pressure is given as Pi. Suppose at time T is equals to 0, where we have only A. So the pressure will be equals to the pressure of A. This will be 0 and this will be of course 0. Next, after a lapse of time T, the total pressure of the system increased by X units and become PT. Suppose I say that after after T time A moles of A dissociates. This will make A of B and A of C. Or I would say after T time the pressure of A is decreased by A, that would result in the same amount of B and same amount of C because the stoichiometric are same. What will be the total pressure here? Total pressure will be Pi minus A plus A, that is Pi and one more A, that is Pi plus A. This will be total pressure. Okay, and it is said that the difference between the initial pressure and the final pressure is X because it is totally increased by X. So we can say that P final, or I am writing it as P total, because the final pressure is P total only, na? So P total minus P initial is given X. Okay, so PT minus P is also equals to A. So therefore A is equals to X basically. Now the rate constant for the reaction is given as What will be the rate constant of the reaction? So it is already given that it is a first order gas phase reaction. So we know that for a first order, rate is equals to what? Rate is equals to 2.303 1 by K. So if it was rate, no, it was not rate. Was it rate? No. So it was T is equals to 2.303 log initial by final. What is the initial pressure? Of course, Pi. What is the final pressure? That is P total is Pi plus A or Pi plus X, because A is equals to X. So Pi plus X. So this will be your answer. So K is equals to 2.303. If you are not able to see it clearly, so let me make more visible to you. Okay, K is equals to 2.303 by T log Pi by Pi plus X. Clear? Okay. Next question. According to Arrhenius rate, K is equals to A e to the power minus E by RT. We know this. K is equals to A e to the power minus E by RT. Now, which of the following option represent ln K versus 1 by T graph? So which graph we need? ln K versus 1 by T. So how you will draw it? Our equation is simply A K is equals to A to the power e to the power minus EA by RT. Now we need ln K. So we'll take ln on one side, ln K, and this will be ln A e to the power minus EA by RT. Good enough. Now we know that ln AB can be written as ln A plus ln B. So I'm using that same property of logarithm. Then ln K is equals to ln A plus ln E minus EA by RT. One more property, if you remember, that ln A is equals to, okay, ln A x is equals to x ln A, right? Hence we can write ln K plus ln A. This minus EA by RT will come here, and ln E value is 1, right? Now if you compare it with the equation of straight lines, this is y, mx and c. X is what? So x is a variable, so it can be only 1 by t. So x is equals to 1 by t. Y is equals to ln k. So we need this graph only. C will be ln A. And what about m? M is minus EA by R. Okay, M is minus EA by R. Now R is positive and activation energy is always positive. Hence, the slope is overall negative. So we'll get a slope with an intercept ln A. Okay, like this, ln K 1 by T, negative slope, intercept ln A. So this will be your answer, right? Slope is positive, it cannot be answer. Slope is again positive, wrong. Slope is again positive. So all of these are absolutely wrong. Next is, consider the Arrhenius equation given below and mark the correct option. Rate constant increases exponentially with increasing activation energy and decreasing temperature. Can we say that? Rate constant increases exponentially with increase in activation energy. No, because it is e to the power minus EA. So if EA will increase, if I just write it here, so A is equals to K is equals to AE to the power minus EA by RT. So if I talk about this fraction alone, so if EA will increase, EA by RT will also increase, because EA by RT, EA is on the numerator. And since it is with a negative sign, therefore minus EA by RT will increase as this value is increasing. And it is power to E. Okay, it is power to E. Now, if this is decreasing, right? If this is decreasing as a whole, then since it is a power, so this one will also decrease. And K is directly proportional to this. So if this value is decreasing, then K will also decrease, right? So rate constant will not increase, it will decrease. Second is rate constant decreases exponentially. Okay, this is correct. With increasing activation energy. And it decreases with decreasing temperature. Means it is saying that it is directly proportional. It is correct. Of course, it is correct, because temperature is on the denominator. Temperature is on the denominator. So if temperature will increase, right, then this value will decrease. And if this value will decrease, then this value will increase, because it is with a negative sign. And this will result in the increase of the final K value. And you know very well that R is equals to K according to rate expression, A to the power something, that is everything. Okay, so rate is directly proportional to K. So if K will increase, R will of course increase. So rate constant decreases exponentially with increasing temperature, inverse relation, correct? And decreases temperature, and with decreasing temperature it decreases. So this is direct relation. Sahi. Okay, B is also correct. Rate constant increases exponentially with decrease in activation energy. This is correct. But does it increases with decreasing temperature? No. Last is increases exponentially with decreasing activation energy. It is correct, but increasing temperature. So increasing exponentially, rate constant increases exponentially with increasing temperature. Yes, this is also correct. So two options are correct here. Okay. D is also correct option. Next option, a graph of volume of hydrogen released versus time for the reaction between zinc and dilute HCl is given in the figure. On the basis of this, mark the correct option. So we have a graph volume, and this is our thing. Now two things are there: reaction between dilute HCl, zinc and dilute HCl, and the volume of hydrogen has been plotted. On the basis of this, we have to plot the correct option. So first is average rate up to 40 seconds is V3 minus V2 by 40. So where is 40? This is 40. So we have V3 minus V1. Okay. V3 minus V1. So is it V1? Okay, it is V1. Okay, so this is wrong. What about this? 40 seconds is V3 minus V2. No, again it is wrong. And here time is also given wrong. So it will be 40 minus 30. Second one is right. So V3 minus V2. So this is V3, 40, V2, 30. V3 minus V2 by 40 minus 30. This is correct. Rate up to 40 seconds is 50. This is absolutely wrong. What about this? It is V3 minus V1 by 40 minus 20. So V3 is 40 and V1 is 20. So is this correct? Say. So this one is correct, right? And this one is also correct. So both are correct. So again, two options are correct. Next is, which one of the following statements, so we are asking about two statements, is not correct about the order of reaction. So order of reaction can be fractional number. So we have seen this. Order of reaction is experimentally determined quantity. Of course, this is also correct. The order of a reaction is always equal to the sum of stoichiometric coefficient of reactant in the balanced chemical equation. No, it is not right. The order of a reaction is the sum of the power of molar concentration of the reactant in the rate law expression. So this is also correct. So the correct option would be, so since it is asking incorrect, which is not the correct statement, so C1 is the correct answer. So out of this, which is not showing the instantaneous rate of reaction? Say, which is not showing the instantaneous rate of reaction? The instantaneous rate of reaction is basically a tangent. So this is the tangent, right? So look it properly. So this line is the tangent. So if you find the slope of this tangent, then our work is done. Okay, our work is done. So V3 minus V2, 40 minus 30. So one is this. Okay, correct. C is correct. So if you look at the tangent, so it is passing through V3 and V2 here at this point. Now, if you look here, then we have again a tangent at V4 and V3. So V4 minus V3 by 50 minus 40. Okay, 50 minus 40. So no one is such. Okay, so this is not correct. Then what we have? V2 minus V1. Okay, V2 minus V1 by 30 minus 20. V2 minus V1 by. So the correct option is, so which does not say the reaction as 40 seconds. So we are talking about 40 seconds. So each of this is giving a slope, which is not giving. It is V5 minus V2. Okay, so this is also not correct. So the correct option would be this one. Okay, this is incorrect. B is incorrect. Next we have, which of the following statement is correct? The rate of a reaction decreases with passage of time as the concentration of reactant decreases. The rate of reaction decreases with passage of time. Of course, this happens, right? As the concentration of reactant decreases. So it is not always correct. For zero order reaction, the rate of reaction is not dependent upon reactant concentration. This is wrong. The rate of reaction is same at any time during the given reaction. So this is also wrong, because since the concentration is changing for the reactant, so for the first order or second order, the rate will change. The rate of reaction is independent of temperature change. This is also wrong. Okay, so as we increase the temperature, the rate of reaction for each 10 degrees Celsius, it doubles. Fourth one, the rate of reaction decreases with increase of concentration. So it says that the rate of reaction decreases with increase of concentration. This is wrong. So which one is correct option? So I think this one is correct option, A. Okay, A is correct option. Although for zero order reaction it does not happen so, but for the rest of the reaction it happens. Which of the following is correct for the rate expression given below? Which one will be correct? Say, for Br minus we have a coefficient of 1 by 5. Okay, we have a coefficient of 1 by 5. And for H plus we have it as 1 by 6. So 1 by 5 Br minus delta T and 1 by 6 delta Br minus H plus by delta T. If you just cross multiply it, so basically you will get, so will it be the option? So 6 is not there, no. If you talk about this one, then it should be 5 by 6 and not 6 by 5. This is correct. Okay, 5 by 6. So if you just multiply this 5 here, you will get your answer. This is not correct. It has no 5. Next question. Which of the following graphs represent exothermic reaction? So exothermic reaction means product is on a lower energy and reactant is on a higher energy. So reactant is higher energy, product is lower. So this is exothermic. Reactant is lower, product is higher. so not exothermic, both reactant and product are on the same level. So del H is 0. So only and only 1 is the correct option. Okay. Only one is the correct option. The rate law for the given reaction is this. Now concentration of B is doubled, keeping the concentration of A constant. The value of the rate constant will be, so the first case if we write, so let me first erase it. So for a simpler case, K, A and B. Now I am supposing that B initial, the concentration is B. The initial time of the B is having the B concentration. Okay. Now it is said that we have changed the concentration. We have changed the concentration to double. So we have doubled it. So if we just double it, suppose B final, it is 2B. Okay. 2B. Suppose I am representing R1, or I would say R initial. Then R final would be K. A. B is now 2B. Divide this both of these equations 1 by 2. What will be the answer? So R initial by R final is equals to 1 by 2. K will get cancelled out, A will get cancelled out, B will get cancelled out. This means your final rate of reaction will be 2 times of the initial rate. Doubled. Next question. Which of the following statements is incorrect about the collision theory of chemical reaction? So collision theory, so basically it says that if your two molecules are colliding, then they should have the enough kinetic energy, plus their orientation should also be correct so that the reaction can occur. So it considers reactant molecules or atoms to be hard spheres. Of course, it does so, and ignores their structural features. Okay, so they do this. So after some time, that collision theory is changed. If you talk about the initial collision theory, it is only dependent upon the collision, and on the effective collision is totally dependent upon the kinetic energy and not on the orientation. So the first one is correct. Number of active collision determines the rate of reaction. Of course, this is true. Collision of atoms or molecule possessing sufficient threshold energy will result in product formation. Okay, correct. Molecules should collide with sufficient threshold energy and proper orientation so to be effective. So which one is correct? So I think this one is correct. Okay, C is incorrect. Number of effective collision determines the rate of reaction. So all of the statement is correct except this one. So I'm not, if you not consider the latest one, so this one is incorrect. A. Next question. A first order reaction is 50% completed in this second. How much time it will take for 100% completion? So for 50% completion, okay, so 50% completion, the time is 1.26. into 10 to the power 14 seconds. Suppose the initial concentration Ri is R. Now it is said that 50% is consumed, or I would say that half of the initial concentration is removed. So what will be left? R final would be simply half. Okay, so if suppose you have a cake, you have eaten half of it, right? You have eaten half of it, then the remaining one is this one. Okay, the remaining one is this part, that the green part. So half is eaten, so half will be remain. Clear? Now next, what is the rate law, integrated rate law for the first order reaction? So it is, if you write it, so it is basically K, okay, K T ln A naught by AT. isn't it? Now 50% is being consumed, and if 50% is consumed, right, and that time is also given, it is 1.26. So we have written this here. So if you write k into 1.26 into 10 to the power 40. Now if you remember, this is half-life reaction, and it is nothing but this value is 0.693. Okay, so if you put a0 by 2 here, a0 will get cancelled, and ln2 will be this value. Therefore k will be equals to 0.693 by 1.26 into 10 to the power 40. So this will be your k, right? Next, what you have to find for 100% completion. For 100% completion. So 100% completion means a0 and this will be 0. Okay, so kt will be equals to ln a0 by 0. Now 1 by 0 is infinity, and ln infinity is infinity. So it will complete at infinite time. Okay, it will complete at infinite time. Next question. Compound A and B are reacting, okay, according to this equation. Now concentration of either A or B were changed, keeping the concentration of one of the reactant constant. Okay, so we have done this kinetic study of our given reaction. Now what we found, so we got this set of data. So if you remember, I've told you during the exercise, so if you're writing this, write in this way such that one of the concentration is remained constant. So if I write it for this first one, so R1 will be equals to K. So A, B, C, we have three things, okay, A, B and C. So if you write it for R1, then it will be K 0.3. Suppose it is, say, I'm saying that it is X order with respect to A and Y order with respect to B. Okay. Next is R2. So R2 will be how much? 0.3 X and 0.6 Y. Correct. Then R3 will be how much? 0.6 X and 0.3 Y. So these are the three equations for these three reactions. Now if I talk about the R2, then what will be the value of R2? Change in concentration with change in time, right? So it is given all. So these are the initial concentration that is already given. Initial concentration by time, that is mole per liter per second. That is your rate of reaction is given. If you put these values here, so that will be, so this will be 0.1, this will be 0.4, and this will be 0.2. Clear? Suppose I am taking this one, I am dividing this and this. It contain a K. K and K will be cancelled out. It will be 1 by 4. 0.3x and 0.3x will be cancelled out. This will be 1 by 2 y. So we'll get 1 by 2 by 1 by 2 y. So of course this power is 1. So with respect to y, b, it is 1. Similarly, you can do it for the next one. Suppose I am taking this one, R2 and R3. Okay, I am taking R2 and R3. So how it will be done? See, so we already have a value of y, that is 1. Let me put it 1 here. Okay, so I am leaving it as that is. Now let us divide this. We just divide this one. So this will be 2. This will be also 2. 2 and 2 will be cancelled out, and it will result in 1. So 0.3 by 0.6, it is 1 by 2. Okay, 1 by 2x is equals to 1. Right? So we can write it as 1 by 2 power 0. Of course, this will be 1. So x is equals to 0, right? X is equals to 0. So is it correct? Let me see again. So we have 0.3 by 0.6. Here it is 0.4 by 0.2. So this is 2. Okay, this is 2. Okay. Right, this is 2 and not 1. Okay, so this is, of course, 2 and 2 will be cancelled out. So 0.4 by 0.2, and this will be 0.6 by 0.3, and this will be 1 by 2x. Okay, so let us see the answer one time. Okay, see, this is, of course, y is coming as 2. So we have counted it wrong in some way. Okay, so if we just divide it 10 by 40, it was 10 by 40. Okay, 0.1 by 4. It is 1 by 4 and not 1 by 2. So this will be y is equals to 2. Okay, so y is equals to 2, then x is equals to 1. Okay, so we have done a mistake here. Okay, so the procedure is important. You will follow the same procedure. Next question. Which of the following statement is not correct about for the catalyst? Okay, so out of this, which one is not correct about the catalyst? It catalyzes the forward and backward rate of reaction to the same extent. Okay, very correct, because it increases both the increase forward and backward rate of reaction by decreasing the activation energy. It alters the G? No, it does not alter the G at all. It is substance that does not change the equilibrium constant. Okay, this is also correct. It provides an alternate mechanism by reducing activation energy. This is also correct. So your incorrect is only B. Next, the value of rate constant of a pseudo-Fosdor reaction depends upon the concentration of reactant present in small amount, depends upon the concentration of reactant present in excess, and is independent of the concentration of reactant, depends only on temperature. So if you remember, so in pseudo-Fosdor reaction, so since one of the reactant is taken in excess, so it the change is undergo does not affect the rate of reaction that much evidently, right? For that reason, the rate of reaction will only depend on the one which is present in less amount. That is option A is correct. Next we have, consider A to B. The concentration of both reactant and product varies exponentially with time. Which of the figure correctly represent the change in concentration with time? So it is saying that concentration of both reactant and product varies exponentially with time. So is this correct? So A is going to be, so it is not correct, right? So this is not correct at all. Is this correct? So of course A is decaying exponentially, but B is increasing linearly. So this is not correct. C is correct, because both are decreasing and increasing exponentially only. So B is correct option. Next is A and B. So here A is increasing. This is not correct. Okay, because reactant concentration will decrease and not increase. So D is of course not a correct option. So B is the correct option. So what talk about? So this is written in wrong order. So A comes, then C, then B. So according to this outlet, so B is correct. Now we will move to multiple choice question times. Means more than one options can be correct. So you have to evidently look at each of this and then decide that what is the correct option.